You worked hard creating your first program, but when you ran it, it terminated with an error. A little disappointed, you sit back and wonder what the best way to handle this is. After a minute, the answer comes to you. Use a try-catch mechanism. You remember the example of a mountain climber using a rope and safety harness while they climb. You realize that you can use the try-catch mechanism as a similar safety device while you're sorting out the errors in the program. Over time, the code you create will be more creative and designed to carry out more complex and adventurous actions. Of course, the daring acts you perform in your code might cause some exceptions. You need to use some protective gear to keep your program safe and prevent it from crashing. This is precisely the role of the try-catch block. It is important to be clear on what each part of the try-catch block does. In your program, the try block should enclose the section of code that could cause an exception. The catch block should contain code that handles the exception. This is the code that needs to run if the exception occurs. As you know, exceptions can be checked or unchecked. Checked exceptions are flagged by the compiler. Unchecked exceptions, on the other hand, are only apparent at runtime. A key benefit of a try-catch block is that you can use it to handle both checked and unchecked exceptions. So, you are probably wondering, how exactly do I write this safety mechanism into my code? Here's your opportunity to observe how you create the try-catch block step by step. To begin with, this is how you can create a try-catch to handle a runtime exception which occurs during program execution. First, create a new class by right-clicking on package L2. Then select New and then Java class. Give the class name as try-catch-test. Press Enter to create the class. Next, type main to add a main method. Select the main method from the drop-down to create it. In this code, you will assume that you need to perform integer division in your program. To achieve this division, you will use the simple division operator /, which takes two integers as input and returns their quotient. You perform integer division in Java by using the division operator. To do this, first declare two integer variables. For example, type int a equals 10 and int b equals 0 on separate lines. Then, type int result equals a/b to perform the division. Obviously, it's important that you know if what you've done is correct. The IDE indicates that there is a problem by underlining the code in yellow. To find out more, hover your mouse over the B marked with yellow. The Java runtime notifies you that this operation may cause an exception if you try to divide by 0. This happens because the denominator b is 0. It indicates that this situation should be handled. So what is the next step? This is the point where you can place this statement within a try block. Type a try block to surround the code. Try block is like the safety harness used by a climber. The line of code within it is now protected by the try block. Next, you need to add a catch block that says what to do in this case. The catch block should be typed below the try block. It should have one parameter which is the type of exception that it handles, in this case, the arithmetic exception. While you could set a catch block to handle the overall superclass type exception, it is best practice to handle the specific subtype of exception if you know it. Type arithmetic exception as the exception class type and E as the exception object as a parameter to the catch block. The catch block can contain any code, but here it will be set to produce a meaningful message. Type system.out.println, open parenthesis, double quote, division by 0 is not allowed, exclamation mark, double quote, close parenthesis. Run the code again. Notice that instead of generating an error, the try-catch mechanism displays your message. This would mean that the program would not be interrupted and crash. This video has taken you through the practical steps you take to add a try-catch block to your code. By familiarizing you with these steps, it has shown you how to handle exceptions whenever they occur. When your program unexpectedly terminated, you were a little disappointed. Now, you can return to it, knowing that your knowledge of try-catch gives you a way to resolve the situation gracefully.